In this video, we'll be talking about something that I'm sure you're all very familiar with, solid phases. Now, it can actually start to get kind of confusing when you're looking at phase diagrams, what exactly a solid phase is. So, we all know about gases and liquids, but of the same material, there can actually be multiple solid phases, denoted here by solid 1 and solid 2. Now, different solids of the same material can have wildly different properties. Take ice, for example. Not all ice is created equal. There are actually 11 different forms of ice. Each one of them exists under different pressure and temperature conditions and is labeled 1 through 11 in Roman numerals. Now, of these, ice 1, 3, 5, 6, and 7 are the only ones that can exist in equilibrium with water, or under the same temperature and pressure. And of these, ice 1 is the only one that floats. All of the others have a positive slope with their coexistence curve with liquid water. So in conclusion, all ice is not created equal. But why is this? Let's look from a molecular point of view. Imagine you have a dishwasher, 3 by 3 squares, and you need to fit 3 orange plates. You can put those 3 orange plates in whatever squares you want. There's 3 of the plates and 9 squares. Let's try this again, but with 7 purple plates instead. It's in the same dishwasher. By fitting more plates, we sort of increase the pressure. We need to fit more plates in the same amount of space. But we can still do that with no real problem. Now let's increase the pressure again, with say, 13 green plates that we need to fit into the same 9 squares. Well, we can't do that with just 1 plate per square, so we need to change the grouping, the way that these fit together, similarly to how an increased pressure will change the way that ice particles fit together. Ice 1, for example, fits in a hexagonal pattern, and ice 7 fits in a cuboidal pattern. Let's say that the green represents ice 7 and the red represents ice 1. Just like you normally won't have to cram in so many dishes into a dishwasher more than there are places, you won't normally see ice 7. It requires a pressure of 30,000 atmospheres to form, but it sinks in water for sure. If you're not working in a laboratory that studies ice 7 specifically, you'll probably only ever see ice 1. That can form under just regular pressures of 1 atmosphere, and it floats on water. By using the effective pressure on crystalline forms, we can predict the density of different solid phases.